Okay, this is the e-NABLE Hangout for R&D of 2015, August 17th, and looks like we've got a pretty close to full house. Yeah, we got 10. Cool. So since you're the one who posted an actual thing you wanted to talk about, John, do you want to start it, or do you want to see, or does somebody else have something they want to start with?
Yeah, I can certainly kick off the proceedings. It's not a very high-tech topic. Just the general topic of Velcro straps, particularly the Velcro straps used with the gauntlet. I do see that I think it's Andreas has posted an alternative strap that doesn't use Velcro. It just clips on the gauntlet. It was either Andreas or Greg Dennison posted that. I think Greg was using it with his son Luke. But just focusing on Velcro for a moment, I've not actually worked with a real recipient. I've built many, many hands for demo purposes for those people, but never actually worked with a recipient. So I've not got the feedback as to what works and what doesn't. When it comes to the Velcro, the first thing that strikes me is that actually having to either sew or stick the Velcro together to attach it to the gauntlet doesn't seem ideal, and I wondered whether or not anybody had any comments on that topic.
Well, some of the things I've seen done involve some of the prints have slots that the Velcro can go through, and they have the Velcro go through and then fold back on the other side, and they'll just use double-sided Velcro to put it all together. I don't know, though. I've not had a lot of time using any of the hands. They don't match my birth defects as well as they do others. So I haven't played around with the Velcro very much. I'm not very helpful. Does anybody else have anything to suggest or any other problems?
I know that when I've been trying to source this double-sided Velcro, I've had tons and tons of problems. I like to grab stuff that I can see, like on the shelves, for instance, Walmart or just any number of other places where you can get that stuff again. So, like, if I find it on the internet, it's insanely expensive, especially if you try to get the stuff that is Velcro brand. Yeah, see, I've seen this. I've used the sticky back, but that actually, it makes it too thick. So that when you'd actually have to size up the gauntlet, and you'd have to size up the hand just to be able to fit that stuff in there.
Double layering makes it hard to slot through everything, and then it's just really thick on the palm.
Mm-hmm.
I would imagine.
One thing I did pick up this week was Velcro brand strapping. This was a 2-inch wide. It's actually 2.1 inches wide in reality, but 2 inches wide strap. It has a plastic loop on the end.
Oh,
a beautifully mounted plastic loop, which I think I'm just going to have to cut off because you can't use it.
Yeah.
The thing is about 36 inches long, but it's got the actual bulk of the material is the loop on one side and plain on the other. It's not hook on the other, it's just plain. And it's very flexible. It's far more flexible than most Velcro I've ever seen. Certainly more flexible than the double-sided. But at the end, the last 2 inches are actually attached. There's a thermal seam at this point. It's not sewed on, there's a thermal seam. And that is the hook section. So you've got the fuzzy bit here, and then the hook bit here, which means that if this is shortened, then I can see that it could be cut and then glued possibly not with hot melt glue. I'm a bit concerned. The recommendation to use hot melt glue, I'm not so convinced it's going to be strong enough. I'm wondering about a contact adhesive might be a better choice, and that would mean that this could be attached with the plain flat side to plain flat side, leaving a fuzzy side touching the wrist, and having a nice flexible bit with also the ability of the hook section to come round the other slot and attach onto the fuzzy section. So this is at least something I'm going to play with. It's not that expensive. At Home Depot, it's about $5 for 2 of these. So even if I've got to throw most of it away, I think this might be a reasonable solution. I'm going to give it a try anyway. I'm just redesigning one of those thermoform gauntlets so that the slot is just over 2 inches wide, so it doesn't slide about when printed at 160%. And I'll see how it goes.
Richard,
Anybody else had any better ideas?
Richard in the sidebar suggests Gorilla Glue. When we have a vacancy, I'll try to get Skip Meats and a few others on. Skip says he's done some things with sticky back that seem to work pretty well, that he would show us when he gets on.
Okay.
So I'll just prepare to send him an invite when we got a spot.
Okay, that was all I wanted to throw in tonight.
Okay, sounds good.
How do you get off the video and watch, or watch live or whatever?
Oh, okay. Thanks, Gabriel. You can come back later in the conversation if you want to.
How do you get off without losing the entire conversation?
Oh, just hit the. If you go to the top of the window, there's a hang up button that looks like that phone.
Okay. All right.
And then you can watch it through the YouTube link.
Yes, sir.
All right. Cool. I will send an invite. If you're watching, Skip, come on in. We'll send an invite directly. Sent. And basically, here's my client up. That's cool. We'll flex that. It's fun. All right. Does anybody else have anything they want to bring up in the moment?
I've actually been working on a parametric prosthetic. I'd like to show if possible and get some feedback on. Would that be okay?
Sure. Yeah. Show us what you got. Like Q&A.
I put a post on the e-NABLE Google Plus page recently, but I'll screen share my SolidWorks. One sec.
Yeah, I just seen your post. That's a really fantastic idea, in my opinion, to be able to make it, I guess, customizable on the fly, as you would some of the other OpenSCAD designs. I think you're really onto something there that'll be really helpful to a lot of people.
Yeah, like right now, but it definitely gets the basics down of resizing, as you can see from the picture. So I'll just share that right now. See if this works. Okay, so you can probably see my SolidWorks right now. This is the base Kestrel model. And a good example for something that I could do would be to edit this part right here. And I can change the profile of the width right here, let's say. I can set at 60 millimeters based off of my user, and it should flare out properly.
Okay, now we've got video.
Yeah.
Sorry, what's that?
Oh, there was a few moments of screen was just black, so your shared screen finally showed up and
Okay.
cut off you.
So should I
If you want to back up and repeat some of it, I wouldn't be opposed.
Sure. Yeah, so basically one parameter that you can change is the width right here. So I can take that down to 50 again. And that should now minimize. So pretty much all elements of it are completely resizable like that. It is kind of tough to do some parts. For example, elongating the palm unit. It doesn't like to be elongated more than 5 millimeters at a time, but it does work moderately well normally. But I guess the idea is you take a battery of like many or like you take tons of measurements of the arm and then input them all in, and now you get a really custom fit. I was working with someone a kid who had a very long hand, unlike what you'd normally like what the rep really didn't work very well because it was too short, and if you scaled it upwards uniformly, it would become too wide. So we kind of designed this to get around that, in a sense. And you'll see, so I just resized right there to be slightly longer, and you can continue doing that. It will stop rebuilding eventually, and you'll need to fix a small error, but it's got some pretty decent robustness. Like I can kick it up to like 60 millimeters width, for example, right there. I like doing small steps because it's more likely to actually succeed, but it should rebuild. That takes a little while because my computer's doing a lot of things. So it gave me a little rebuild error there, but in general, it works moderately well. I just need to do small steps.
That makes sense.
Yeah. And I'm kind of concerned. I don't think anyone like. Does anyone use SolidWorks, or is it mostly Fusion 360?
We use lots of things.
Okay.
Yeah, a lot of people use different things. We use a lot of Fusion 360 because we have a lot of support from Autodesk with it.
Yeah.
And it's a free product, so a lot of people are able to use it.
Mm-hmm.
I use OpenSCAD personally for my designing, but I haven't allowed other people access to my designs or anything that I've been doing. So that doesn't help anybody. But everybody's got their own thing they're comfortable with. I think that Peregrine and Peter are using
Blender.
Yeah, Blender.
Okay.
So a lot of people are using different open source CAD softwares.
Mm-hmm.
And Scott Darrow is a good person. Yeah, 3ds Max. Scott Darrow is a good person to talk to. He was talking to somebody else who's very, very new. Can't remember the name, but they've figured out how to port things from SolidWorks to other things and back again, and that's been a big problem for us this year. So that would that would be a big step forward if we were able to do that. I think it's something about taking it through 3ds Max. So,
okay, but do they? But sorry, do they rebuild feet? I'm sorry, there's a bit of lag.
Go ahead.
Do they rebuild features when you change like between CAD programs? Like, because like as far as like rebuilding a model goes and having it be parametric, it's kind of dependent on having like individual features and not just having it as a solid body or a mesh. Like, is there a way to like keep the features in a sense?
That would be something to talk to Scott Darrow and the other guy about. I'm not real sure. I'm not familiar with all the softwares and stuff. I just remember people having trouble with errors and triangles and rectangles, and so it would be a good thing to talk to them about because they figured it out.
I've found this using taking the STL and utilizing FreeCAD, and FreeCAD with about a 5-step process that's actually available on a YouTube video will let me convert it to a step file very easily. And once a step file, I can manipulate it very easily in Inventor. If that's, I mean, it would be similar in SolidWorks.
Well, yeah, it's just a matter of getting it from SolidWorks to other things or from other things to SolidWorks. That's been a big problem for us.
Yeah.
There's been errors and all kinds of stuff. That's why I figured it'd be good for you to talk to Scott and also Nick Norris. He's done some work on that as well.
Also, if you've got a link to that YouTube video showing how to use FreeCAD to convert STL to step, that might be a useful thing to post in the comments section.
Yes.
Yeah, no problem. I'll add that.
Thank you.
All right, so welcome aboard, Skip. You were going to show us your sticky back Velcro trick?
Yes, can you hear me? I'm on.
Yes.
Okay, great. This is an arm that we've been working on. We're calling it a training arm. And this particular arm I have in my hand, I tried on our test pilot, whose name is Lucy, and you've seen on many videos, and she liked it. She hasn't taken it home and really tried it out in real life, but you can see instead of having slots on the cuff that holds this arm onto her upper arm, I've got sticky back Velcro with the loops just stuck on a flat cuff, I'm calling it, and it's like the printed flat gauntlets that are thermoformed, but I've left off the slots, so I've just stuck the sticky back Velcro on there. It's the heavy duty kind, and it sticks very well. And then somebody was showing some Velcro earlier on 10 minutes ago that is just the fuzzy loop side on one side and just fabric on the other, and that's what I'm using.
Fabric side against the skin.
Attachment. And Lucy can put this on and off just, effortlessly. I'm using the same thing on the part that goes on her residual limb to hold that together. Also, the sticky back loop and the sticky back hook and the soft fuzzy loops against her skin, and that's working well for us.
Very simple. I'll be interested in seeing after it's been applied and pulled off and applied and pulled off multiple times if the adhesive on the back of the sticky back starts to peel off the plastic.
The heavy duty stuff's a little bit high priced, but
yeah. But the other nice thing about it is
it's going to prove to be worth it.
Yeah, with the cheap stuff, if it does peel off after a few hundred repetitions, then it wouldn't be a big deal to replace it.
Right. So don't have much history on it yet, but I sure hate the kind that you have to have the slots on the gauntlet.
Right, to slide it through and put it back.
Yep, I very much like that approach. That gets, as you say, past those horrible slots that, when they're printed in the original 3D design, are hell to print. And they're just weakness in the design. They mean you have to put glue on the Velcro. It's just bad news. And I think what you've done there is so simple and elegant. That's what I was looking for.
I tell you what, John, I'll be publishing this kind of details of this design in the next few weeks. But my experiments have shown me that using 0.1 millimeter layers, I can print a cuff flat that is 1.2 millimeters thick. So that's really thin. It's very flexible, but that's 12 ply. It's like crisscrossed layers of plywood, 12 layers thick. But each layer is only as thick as a sheet of paper, and that's good. That's what you see here, and print it flat without slots. And if it's PLA, you can just dip it in hot water and bring it out, wrap it around a piece of pipe to get it to approximately the right size, and dip it or use a heat gun and get it more precisely the right size. But I think that's going to work out for us on the arms, and I don't see why it wouldn't be an improvement on the gauntlets for the wrist-actuated hands also.
Yep, I like it.
Give it a try and let us know what you think.
I'll do that. In fact, what I'm going to do is redesign a gauntlet, a thermoform gauntlet. I'll take the slots out of it, and I'll go and get some of that heavy-duty hook material.
And I would recommend, if you've got, I'm using Ultimate Maker 2, and printing at 0.1 millimeter layers is what they recommend. So it takes a while, but if you make it real thin, it's not so long. And I recommend that. 1.2 millimeters thickness altogether is just fine.
Okay, I'll see what I can do. Thank you.
Oh, and there's one more thing, John. The designs I'm using with the cuff on the arms, I'm adding the hinges with little rivets that I make out of 3mm filament, and use a hot iron to put the little button head on the end of the rivet. If you print the gauntlet flat and add other features to it after it's thermoformed, it has some advantages. I haven't experimented with that with the track that holds the tensioner and the hinges and so forth on the gauntlets, but I'm just mentioning it because if anybody wants to experiment with making just this thin, flat, flexible part to be thermoformed and adding the features later with rivets, that also is working for me on the arms.
Yeah, that's pretty useful. That style of Velcro. And like I said, I'll be very interested in seeing how it puts up with heavy use. But it seems like it would be a cheap enough answer that it wouldn't matter if it didn't. We'd be able to replace it cheaply. So, Keith, we made a little bit of effort. Lydia wanted me to make sure you got on. Did you have something you wanted to bring up or to talk about?
Sorry, I was muted there. Can you
No
hear me
worries.
okay?
Yeah.
Can you hear me?
Yeah, we hear you fine.
Oh, okay. Yeah, sorry. Yeah, no, actually, I just wanted to introduce myself more or less, and I've been watching and listening. Last week I did have a question, and it was a lot of back and forth on the text and all that. So part of it was just to introduce myself. Part of it was to familiarize myself with how this whole I've done, Hangouts before, but never a multi-Hangout live that was recorded, went to YouTube, etc. So part morbid curiosity, part just to say hi. I did, though, have a question about the arms. On the, I know that's a huge sticking point for us. That's more or less shut down our arm making essentially, and wanted to see what really could be done about this. For me, I've never tried one. I've got the lowest end printer that still runs. I don't know if I'd be able to do that, but I've just started to get access to Delta Maker printers. I don't know if you're familiar with them. Just an amazing machine, so they're Castle printers, so the bed doesn't move. So holding things tall and intricate is not a problem. So I wanted to start playing around with those. I was curious, more or less, what is the biggest? I mean, obviously, it's a lot different making an arm than just the hand. But what is the big stopping point? Why is it that enough people, more or less, can make hands, yet it's so much harder to make an arm?
I'll try to answer that. The hands are not so critical for how they fit to the recipient's limb. They're more forgiving. If you can see, if you've got a cantilevered device hanging out that you're trying to support with a residual limb that may be only 3 inches long. Lucy's arms, only this long past her elbow. And so a big heavy arm hanging out on that, it's got to fit very perfectly in contact with her skin in order for her to have control over the arm. And it's the clinical part of fitting the device to the recipient that requires some extra skills and knowledge that is not so much necessary with the wrist-actuated hands. So the arms are tricky, and the original RIT arm never was developed far enough, so we felt that the average volunteer could be able to handle it comfortably and successfully, and so we considered it experimental all the way through to now. Some people like Nick Norris have made some great improvements on it, but it still was not really ready for prime time, in the opinions of some of us. And so the new arm that we're working on, we're calling it a training arm, and its idea is that it's not going to be, we're not going to promote it and provide it as a substitution for a prosthetic arm, but as sort of a training device that a child may be able to use to get ready for an arm provided by a prosthetist that is truly fitted and functional. And there are several things about where this is right now. It is modular, and so all the parts can be replaced really easily from one to another. You can take the terminal device off of a prosthesis that's provided by a prosthetist. It may be one of those Hosmer hooks that's a split hook that's held together by a rubber band, and it's operated by a shoulder harness. Well, you can take that hook off and put one of our e-NABLE hands on in its place. Our modular system.
Yeah, I think you showed that last week. That was really cool.
And the other thing that I've got going that you might not have picked up on yet is the whole arm is printed flat and then thermoformed into the cylindrical shape. And then it is thermoformed right around the residual limb. And the techniques for doing that we're still working on. But Jeff Aronstone, our favorite prosthetist, has taken one version of this particular arm to a child in India. He's on his way there right now. And so we're beginning to get going with what you might call the alpha testing level. And we're going to be looking for beta testers to try it out on people who already have used arms, fabricators that have already provided arms to people, and they can compare and give us feedback on what's good, bad, and ugly about the new design. And there's a conference coming up at the end of October, and we're going to try to be ready to make a big presentation of a design for that conference. And I feel like we're on track for it. There's a hangout on Fridays at 1 o'clock Eastern Time. And if you're interested in joining that, contact me, or Daniel Dugan is hosting that. And we'll be happy to have anybody who's interested to participate. Keep an eye on the forum. We're going to start soliciting input and beta testers on the forum within a week or two.
And Lydia posted a link to the forum in the sidebar chat if you guys are paying attention to that.
Cool.
So,
well,
yeah. Sorry, go ahead.
I was going to say that I was talking with Bob, who started Delta Maker today, and he's very interested in helping us out. When I was there, he had a bank of 6 of his Deltas at the back with nothing running on them, and as soon as I told him the link to the K1, he set 2 of them off to race to see which one built one faster. And he now has the Delta 2T or something for tall, but it'll build 18 inches tall and a hexagonal base. But he said that send him a link to the files, and he'd love to get started helping print some arms, because I was telling them that that's really one of the more challenging things for us, is people that can actually, you can, you know, say, hey, print me an arm, and they can actually do it, you know, in a relative turnaround. And
it'd probably be
so,
good if you go through the regular process through our e-NABLE matcher. You know, sign
yeah.
up.
Oh, I mean, he's a member.
And go through that regular process and join into our Google groups, and there's lots of opportunities through those regular channels to provide hands. We're looking for a bunch of hands to take to the conference in October, because we're going to have workshops for people to, you know, assemble them and put them on kids there in Seattle.
Oh yeah, I'm quite familiar. He's actually, that's one of the things he's helping out with. In fact, I've made a half dozen of them this week, and he's loaning me one of his deltas so I can punch out some more. But he is a member of the e-NABLE community, Google Plus and all that, and he actually did have some kind of link to whatever file was new at the time, but you know, he hasn't visited that in a few months, and I just ran into him at a local Orlando meetup, hangout type of thing monthly. But anyway, I had remembered on the town hall meeting last Friday, somebody had said something about, oh, I'd like to make this hand, where do I find the file? And John said, well, maybe you could do this new one. It's not quite ready, but you know, maybe we could start trying that one. So if that's what you're talking about, then I'd love to get a link to that to both try myself and to let him have a shot. He's
great.
He's got quite a lot of resources there.
Yeah, so keep an eye on the forums. It should be available in a couple of weeks.
Okay.
Good to know. And I guess the other reasons that that the full arms are a little more difficult than the palm actuated ones is that palms are actually a little more friction resistant. They have naturally callousing skin in your palms, so they're a little more tolerant of the sliding around that they do on your hands. A lot more skin that is a lot less able to put up with friction is in contact with the prosthetic in the arm designs, and that's why it takes a lot more care in the thermoforming and the shaping and making sure that it fits like it's supposed to. There's a lot of reasons why it's a little bit more complicated and takes a little more skill than just printing. So, I don't know, is anything else going on? Do we have any other, anybody else have anything they wanted to show and tell, or anything else they wanted to talk about or ask about? Oh, Nathaniel says, a number of recipients don't even have palms, so I'm not sure what flesh they would have there. Yeah, but a lot of the wrist-actuated hands, a lot of them do have palms. And I imagine we need to take extra care when they don't. They may not have a lot of palm to actuate against, but some is required. Whereas with the ones that Skip is working with, those don't have any. Those often don't have anything past. They don't even reach the wrist in some cases. Well, he's talking about earlier, her arm only goes a few inches past the elbow. But no, you're not wrong about that. A number of the recipients don't even have palms, and often we'll take extra care to make sure that they have socks to put over the over what's at the end of their arm or over the wrist. Sometimes they'll research of what type, Nathaniel? What do you? I talked to you in the past, but I need a reminder as to what it is that you, what your background is. Understood. Yeah, Peregrine loves to use socks because you can put them in the laundry and they absorb sweat well. Yeah. When I used to wear splints a lot when I was little, we used basically material that was a lot like a sock that just went over the portion of the arm that was in contact with the plastic for exactly those reasons. It absorbed sweat well and was easy to throw in the laundry. And they sold the stocking material on rolls, so you could cut them to the lengths you needed, and then you could have a whole bunch of really cheaply purchasable sleeves that you could put on when you put a splint on. And socks are also mass-produced. They're easy to get a hold of. They're fairly cheap, and they are good in high friction, and they absorb sweat really well, and they're really easy to take care of. So I posted the YouTube video that you shared with us, Jesse, onto the into the comments, and okay. I will probably ask somebody to copy and paste the sidebar chat. Let me go create a Google document for that, and I'll share that with everybody in a minute.
I found it extraordinarily helpful.
What's that?
I found it extraordinarily helpful because a lot of times, even with Inventor Professional, it's hard to manipulate an STL mesh, and that makes quick work of conversion.
Yeah, Charles Wayenthal in the Q&A mentioned stockinette, which is with the rolls of tubes of fabric that are like socks were called. Gabriel Medina, let's see, 1, 2, 3, 4. Gabriel, if you want to, come on in. If you want to talk with Eric, we've got one space, so come on in. We're still at 9. Let's see. Oh, Gabriel wants an invite. Okay, I do it that way.
Trouble, I think I'll sign off and take a passive role for the rest of the evening, and you can use my slot for somebody else who wants to join. But thanks.
Okay, I can do that. thanks for joining us. You are always helpful. Since we're going back to Gabriel. I wonder if this is another case of if you jump off, you can't jump back on, like happened to Richard. Well, Richard didn't jump off. I kicked him off, thinking that he was a duplicate of the other Richard. There had 2 Richards in that day. Oh, Charles has a Q&A question. I will jump on that. Yeah, I didn't mean to. Sorry about that. Let's see. There it is. Let's see. Charles Wayenthal asks, what is the status of using the Raptor 2 rubber band hands as the approved version? I'd like to discuss the typical sizing and methods to produce consistent ratios for rations for interchangeability, that is steps in 2.5 or 3% depending on the letters, and using letters to define sizes. Then 2 of 2, he says, this will then allow labeling of the main parts and part subsystems with letter IDs for easier kitting and color sorting. Using OpenSCAD, we could then use scripts to create size files that have the lettering included in the print. Go ahead and select his. I don't know the current status of the Raptor 2. Thanks for copying that into the sidebar chat, Lydia. And I do like the idea of using letters to define each part, or using some sort of labeling that we could standardize to show each part. Ah, you got in, Gabriel.
Yeah, all right.
Cool.
I don't know how I did that, but I got on through my phone. And I don't know that
phone connects
Eric, I don't know that Eric can get on either. So
let's see if I can invite him. Eric Griffin, right?
yes, sir. And now I can hear myself.
Invited. Yeah, I don't have answers for Charles Wayenthal at the moment. I'll ask around and see if I can have something for the next meeting, or have something to post in the comments.
Can you turn it down a little bit?
Possible, but the join link that I have is
If you can, I'm so sorry.
the join link that I share is generated on my end, so I'm not sure. So I sent an invite to Eric. Let me see if I can grab him in another chat window, and I'll send him the link as well.
Hey Eric, how's it going?
Ah, you made it. Cool.
I'll get us started real quick, Eric. We're actually trying this week to get a printer ready that we're sending to India. This is alongside one of the very many we hope to send to other countries that we can do e-NABLE stuff and quite a few different other things with other groups that are going out and using printers. So what we're trying to do is get these printers free or of extreme low cost to the groups that are going out. We have, I think, 3 designs, Eric. Is that correct? I think we have about 3 designs that we can send out. None of them are extremely polished, but they're very close, very close. And of course, being the mindset that we're actually able to change a lot of what the printers can do on the fly, and that's pretty awesome, I think. Eric, do you have anything else to add?
No, other than your printer is coming along well. Can you hear me okay?
Yes, sir.
Yes, we
Yeah.
can.
I think the last of the components we needed, we fabricated the last of the stuff this afternoon, and some of the other parts came in.
Wow.
It should fit fine.
Perfect.
I thought it was going to be difficult when somebody spec'd a printer to operate in any orientation, including inverted, over high dynamic loads in a 50C operating range. I thought they were insane. That was actually easy compared to getting a machine that folds into a carry-on bag.
And that was my request, by the way.
You have it. It is short enough. It fits. It is within the 22 by 14 by 9.
Fantastic.
It fits in a rollable.
Wow.
You guys can imagine the things that this opens up. I mean, people can take them on a plane with them instead of having to worry about an entourage of people unloading stuff like we've seen in other videos.
Right. Although I imagine the conversations with TSA get interesting.
Right.
That one may be interesting, but I didn't have to worry about this one handling extreme thermal shocks or being under the belly of the plane either. So
and we'll find out soon.
Carry on if you can get away with it.
Yeah. And we'll find out soon whether we can load it up on a plane or not. Wherever they'll have to check it. Hopefully, we'll be able to carry it on. Just have to look at just find out by going through the checkpoints.
Well, check the other end, because in the U.S. they care about size. I've never seen anybody weigh a carry-on bag.
Right.
Whenever I'm traveling New Zealand, Australia, not sure. There particularly, they get really picky about the 7 kilo limit on bags and things like that. They'll weigh your carry-ons, not just look at the size.
Mm-hmm.
So make sure when they're at the other end. I know they can get bored in international flight with a carry-on.
Okay.
American specs. Once they branch out into secondary, local India flights, find out what those airlines are going to require. This may be required to break into the bags, which is perfectly fine.
Right.
They're just not going to want to do that on the side of a terminal.
No.
So figure that one out ahead of time.
We wanted to know if anybody had any questions from us. I know that somebody else that just popped out, I think, was working on printers. But if anybody else has knowledge of maybe somebody that's going out that might need one, or those kinds of things, we'll have pictures with this one, and we'll be able to go a little further with those. But anybody who has a legitimate need for this kind of thing, or this opportunity, rather, that would be awesome. Just let us know, either one of us. I think that's it.
Cool. Yeah, you guys have been doing some really interesting things with printers.
Well, thanks. Their idea is, I mean, e-NABLE is great at developing hand designs. Really, really good at it. But there's only so long, and there's only so many people that can be reached by taking orders, printing them halfway around the world, and mailing a hand. If we can get clinics and start to be able to produce some of these designs on site, solve so many logistical hassles. You know, we don't need to be, you know, to use the whole thing about teaching somebody to fish. We don't need to be taking orders, catching fish, and mailing them halfway around the world. We need to send some fishing boats.
Right. And that's the promise of 3D printing and rep-wrap style designs, is that they will and should be easy to transport and reproduce and replicate.
Mm-hmm.
So,
my experience has actually been precisely the opposite. Unfortunately, a lot of people might take, you know, umbrage.
Yeah. So easy is the wrong word. Possible.
Well, even reproducing them on site, more printers doesn't help, and rep-wraps,
Right.
as finicky as they are, and they still require you to import almost all of the, you know, correct pieces, and it requires the training, it requires laptops to be plugged into them. There are fewer skilled personnel than there are, I mean, giving everybody a rep-wrap doesn't matter. If they don't work, they're not trained to fiddle with them, and not the trained person around. What I'm finding is what they really need are some really solidly, even overbuilt printers that simply don't fit. You know, we can't use borosilicate glass on the printers because here we break it, we pick up another piece. There it's not possible. That's why we're using ceramic coated aluminum ones. You know, build plates, things like this. They need to be a printer that doesn't fail. And that usually means expensive and not easily reproduced elsewhere. But I'd much rather ship in one printer than having people ship in 1 million parts for rep-wraps that they're never going to be able to maintain or keep getting parts for.
Yeah. That's the thing that's the thing about that promise is it doesn't help if it's remote enough, because there are parts that need to be bought off the shelf still for the rep-wrap, and they're not as rugged as they need to be. But what you guys are doing is helping make that promise more of a possibility. You're helping keep the promise, because we're not there yet.
Yeah, I would rather one printer in a clinic in a 50-mile radius or something that everybody can get to, rather than 100 printers that are going to operate possibly for a short period of time, if you can train that many people to even use them, and there's not that many laptops to go around. I mean, there's another gigantic infrastructure, not just clean power or anything else. It's the training, it's the computers. There's so much of a support network that's needed to run a rep-wrap or any printer, that having one or two in clinics that will run for years without failing is probably better than 1 million that are going to break down in a couple of months. It's just the experience we've had. Even people who've taken good printers, MakerBots, whatever, out into the field, and 5 years, you know, or 5 printers go out, and 3 weeks later there's one running because they're having to scavenge the rest for parts. You know.
Right.
It's not 5 years; it's 5 days, and they're already having trouble. They don't transport well.
Yeah, they don't survive the shipping very well.
And even issues where people have to stay awake all night and sit around and watch them print, because you can't leave them print with a laptop attached, because a laptop will disappear.
Right.
I think what's also pretty spectacular about the system that we're working on, or that Eric's working on rather, is the fact that you can actually attach different tool sets to it, not just the 3D printing head, but a myriad of tools that you can actually use to to just make pretty much almost anything. And I thought that was pretty fantastic. To be able to have that kind of flexibility to do stuff in the field. And, you know, the one going to India is specialized as a 3D printer, but let's say that there's an extreme remote village with great electricity running through it or whatever, you could actually go in there and really improve their life just by adding this tool to their arsenal. So.
Yeah, now the 3D printing, the rugged 3D printer I can handle. The multi-head unit, it's really, really good still as a consumer level product or something in the developed world. I'm not so sure the interchangeable head is ready for prime time and shipping to remote locations. That one has not been proven very well.
Right.
I'm not as comfortable with the interchangeable head unit. But then
CTC
again,
is releasing one.
What's that?
CTC is releasing a new interchangeable head model for, I don't know, I want to say around the $800 US. It's got a printer, a laser, and a router. I've really loved my Creator Dual. It's pretty rugged, but definitely doesn't fit the size constraints for airline travel. That would be fantastic.
Well, Boxy, I believe, and I think Ultimaker tried to do the same thing. The limitation with the laser, though, was I think they're using like a 2-watt LED out of a Blu-ray laser player or whatever, which was way too powerful to be safe and not powerful enough to do functional work. I thought that was a pretty dangerous combination. But I do like the idea that you can put a Dremel on it and prototype circuit boards and do 3D printing.
Here, real quick, check out Octopi and OctoDroid. Made comments in the chat.
Your mic up a little bit.
Yeah, and can you adjust Eric's mic up a little too?
Yes, I can try. I can't get to Eric's. He doesn't fit on. Yeah, the Q&A app doesn't allow me to slide up and down through all the people that are involved in the conversation.
You mean control room?
Yeah, control room, sorry.
Okay. There should be a slider on the side that does that.
There is not. I'm wondering if it's because I'm using the wrong version of the Hangouts tool for the operating system I'm currently in.
Right.
But yeah, I can't touch.
Eric, can you turn up your volume at all on your computer or something? Or your mic, rather? Huh. Maybe he's frozen.
Yeah, he might be. Go ahead, Nathaniel.
I was just saying for Steven, it's like you should check out Octopi and OctoDroid if you're worried about someone stealing his laptop while he's printing. OctoDroid that runs off of an Android tablet, preferably a good one. But Octopi, $25 for the Raspberry. That's it.
Oh, you're talking about the Octoprint and Raspberry Pi devices?
Yeah, Octoprint for Raspberry Pi and OctoDroid for Android tablets.
Yeah.
It will save his laptop from stolen.
Those would be the answer. The Octoprint is a tool that is used for monitoring print jobs. It's a small embedded computer that can be attached to the printer that you can feed the files into over the network, and it will monitor the print. You can give it a 3D camera, or you can give it a camera that it can monitor the 3D print as it's going on. So you can check it over the web if you had web access. In the cases that you don't, it's still a much cheaper computer that could be attached to a printer that wouldn't be useful outside of the context of the printer, so would be less likely to be stolen and cheaper to replace if it were stolen.
Or in that context, can be built into the chassis, so it's not an issue.
Right, so it's not reachable, can't be gotten to. But yeah, Raspberry Pi boards are in the $35, $45 range, and you can sometimes get them much cheaper. And they support a lot of really interesting features, including you know, Wi-Fi control of your print jobs.
I'm going to have to check that out. Right now we're using a Beagle-based unit to do something very similar, but yeah.
I think that there are Octoprint. I'd be surprised if Octoprint hasn't been ported to the BeagleBone. Let's look and see. They are octoprint.org. I'll put that in the sidebar.
Beat you to it.
Yep, you did.
So Joshua Hicks has said a couple things in the Q&A.
Okay. Do you want to read them, or do you want me to scroll back for them?
Yeah, well, when he wasn't talking to me, he was talking to you guys.
Okay. Hold on one second. I'm browsing through the Octoprint website. Yeah, I mean, you can run Linux on a BeagleBone, can't you?
You can. In fact, we're running a Debian-based system right now, and we use that to scale and slice and plate files, and then can print them directly from there.
Yeah, it looks like Octoprint is Python-based, so shouldn't be too difficult to download and install on anything that can run a Linux distribution. The hardware control might be funky. If your equipment involved a camera or something like that, it might need special drivers built for it or something to get it to work on different hardware. But they have quite a bit of documentation on their website, so it would be worth looking up and reading through. Go to the Q&A.
Google Plus community too.
Say that again?
They have a good Google Plus community too.
Right.
Hey John, I see the comment about printing from an SD card, which is awesome, which works in a lot of cases. In this case, we went a different route because we wanted to be able to pull up a library of part files and be able to scale them and slice them and print them without having to go to an external computer, just from the touch screen on the unit. So more complicated, but in areas with no internet, you have to have a library of parts or it doesn't do you much good. So, which I guess you could do from a PC to an SD card and move it over, or do it wirelessly over, but we're trying to avoid that, so we can do some limited amount there within the printer itself without leaving that. People still there?
Yeah, hold on. I'm trying to find
more complicated way to handle
comment in the Q&A that Lydia was asking about.
Thank you for the link, Nathan.
Oh, nice.
My pleasure.
All right, let me see if I can invite Joshua Hicks directly. Yes. I'll send him an invite. Oh wait, 2, 3, 4. 5, 6, 7, 8. Yeah, we're still at 9, so we should have room. Hey, Joshua. So we saw you were had some questions in the side or in the Q&A. Feel free to ask. Also, did the rest of you see the link I posted to the sidebar chat notes? Do you think one of you could copy and paste the sidebar chat into that document? There are 2 versions of the Hangout client for Chrome. There's one for Chrome running on Linux, and there's one for Chrome running on Windows. I have the one for Linux installed, but I'm currently booted up in Windows, and therefore I don't have access to copy and paste features in the sidebar chat.
Hello.
Hey, Joshua.
Hi, how you doing?
Not bad. See if I can adjust your volume. Get a little louder. I have the one for Linux installed. Are you on the phone or are you on your laptop? Therefore, I don't have access to copy and paste features in the Hey, could you turn off the YouTube video or mute the YouTube video so that we're not getting that 2-second delayed repeat? Could you turn off the YouTube video or mute the YouTube? More like 4 seconds, I guess. Probably in another tab or on your Windows machine.
And a question about those microcontroller, like the Octoprint, Octopi, all of that. Those are the file and then passing over to the RAMS controller. Is that correct?
Say that again?
Oh, the Octopi or whatever being plugged into a printer. That just spools the file to the Arduino or the RAMS controller. It's
pretty much
acting in many ways like an SD card if you just plugged it in.
Yeah, it's kind of acting like as far as the printer is concerned, it's acting like a interface to the SD card. As far as the network is concerned, it's acting similarly to a print server.
Okay.
So it's got a Wi-Fi address that you can connect to. It's got a web-based interface to control the prints. It allows you to drag and drop STL files or G-code files onto it to allow it to do the print. I think it's got a slicer, but I'm not certain of that. You might need to slice it before you use it. But it's probably better if you slice it on your own computer because the Raspberry Pi is not very high-end. Or the BeagleBone.
The Beagle can do it, but it takes a lot to do it, and you have to program. Yeah, we actually got a couple of the real-time units to sit there and do just that by itself. You have to get into the firmware and really mess with it. We've also got an FPGA involved. Even the even the BeagleBone Black has a difficult time with some of it. A Raspberry, I'm not sure you'd want to do it.
Right. But they've got a web-based interface. I think they allow you to drag and drop files. If not, there's a download or upload dialog that allows you to upload G-code into it, and then it'll do the print, it'll schedule the print, it'll allow you to queue up multiple prints. It, if equipped with a camera, can do periodic photographs of the print so you can glance at it through Wi-Fi or such. It's got a lot of really cool tools. It's worth looking at and reading about. There's a lot of web videos out there showing the Octoprint, showing people printing things, and it's kind of cool what it's capable of. I think that if it's equipped with a Wi-Fi USB plug, that it can be set up to be a Wi-Fi hotspot that you can just walk into the room with your laptop, connect to it, and then start doing the file transfers and stuff. But I'm not sure. It might need an external Wi-Fi hotspot. I mean, it's a Linux distribution. It's based on Raspbian, so so any Debian or Ubuntu-based operating system running on an embedded system should be able to be ported. Actually, Octoprint runs on Windows devices too. There are people that are using Windows laptops to monitor their prints and things like that.
Well, we're running Debian on the BeagleBone Black, so that shouldn't be a difficult thing to deal with. I'm sure it's only set up to run RAMPS controllers, and we're not using those, so the interface might be a little dicey, but probably it's something to look into. Probably could be modded pretty easy.
Right. Yeah, it looks like it's got a lot of... Yeah, there's a version of Octoprint for Linux, for Windows, for the Mac. Let's see. Yeah, I'm not sure how it accesses the RAMPS board or whatever other board is in use. I'm not sure what the restrictions are for what kinds of control boards it can use. I don't know those things. I've got an Octagon. I mean, I've got a Raspberry Pi sitting in my house not being used. I probably ought to hook it up to my printers and see if I can learn how to use this and see what it supports. Let's see. I'll have to research that one. I've actually got only that on my mind. I've got enough things that I'm looking at.
Yeah, has anybody played with a Matter Control tablet yet?
Which ones?
Matter Control?
No.
I'm sure you guys have printed using Matter before, but... No?
I haven't. Matter Control.
Yeah, well, they've basically installed it, ported it over to, I believe, an Android device, put it on a tablet, and
Nice.
I believe replaced probably where the battery fits with I'm not sure, a little bit of hardware to interface and do much this sort of thing. It's basically a ramps controller and the slicer and everything on a tablet, big thick tablet that has to be plugged in. It doesn't have a battery to run it, but you can take it, and it's a touchscreen interface you can attach to your standard 3D printer, and it's got configuration files for like a couple of hundred standard 3D printers. So you can move it immediately over to slicing on board, but it's slow. But you can do everything on one tablet, and you can retrofit it to existing printers.
Wow. I'm looking at the website right now, mattercontrol.com.
It's like what, $300, some 400. It's not that much
for the tablet.
Yeah, it's like a 10-inch tablet or whatever, and slice and plate and print and do everything right there. Even though still, it's a tablet. It's not going to be real fast at slicing big files, but.
Right, but for use when you're out remote, it might be a really nice way to handle it. Is it the Matter Control Touch?
Yes.
That's really cool.
It is. It's pretty cool. It's limited. It has its limitations, and it is pretty limited, but it's inexpensive, and as a first step, I think this is kind of where you're going to see printers go. And they've talked about some OEM applications. I have a feeling there's going to be a number of major printer companies that are shipping these things.
There's a link to that particular tablet, I think.
I have a feeling full touchscreen interfaces are on the way. The technology's gotten there. People just are still... Open source is neat, but it can be an echo chamber, and I think the days of using an LCD and an Arduino are past. There's just so much inertia there, and there's so much development that's been done. But things have gotten so cheap. Raspberry Pis, Beagles, touchscreens. I think we're getting to the point where people are going to be controlling printers through an Android phone, not through an LCD and a couple of buttons.
Yeah, I suspect there's enough processing power on Android phones these days that it shouldn't be too far off that we are doing a lot of this kind of slicing and printer control from Android tablets and phones and other devices. Sorry, I'm grabbing links and copy and pasting them.
I tend to concur with the sidebar thing there, Nathaniel, but it's got limits, but they're trying. But I think I'd go more your direction there.
Oh, right, the Octodroid. So you use it on your phone when you're when you want to, but when you're done, use your phone as a phone or use your tablet as a tablet. The magic cross. Nice. Yeah, the sidebar chat is useful when people are having microphone problems because it's a lot easier to type when your microphone's not picking things up. But I always feel a little embarrassed because that leaves people who are viewing through the Hangout on air out of part of the conversation. Also, people who are using the client on their phone sometimes can't see what's going on the sidebar. So, anybody else have anything they wanted to show or talk about?
Nice.
That's cool. How much, so that's a Ninja Flex brace.
Thanks.
How rigid is the hinging? The part where the
Well, I mean, this would, I've just finally got in touch with the, recipient, so I've never had the opportunity to physically put one or have somebody use it, but, it'll hold my coffee mug up and barely compress some, but
right.
it can go fully flat and then pop back. I guess I don't know. That's kind of something I was asking earlier in terms of has anybody else previously had any success or maybe difficulties using the soft materials?
Well, Steve Wood uses Philoflex for everything, it looks like. He's Gyrobot, or Gyrobot. He's the designer of the Flexi Hand.
Mm-hmm. Oh, wow.
So he uses flexible materials for almost everything.
Okay.
He's doing a lot of interesting things with it too. He's also playing around with like shoe insoles printed from a scan of your feet by putting your foot on top of a scanner and use it in a dark room and using the light levels of your feet to determine the distance from the plate so that you can create a 3D model of your foot to turn into a 3D printed insole for your shoe.
I'm sorry. I was trying to find a sample of another TPU, different vendor, and the hardness rating and everything is almost, available in a variety of different selections.
Yeah, the tricks with the flexible filaments is if there's any gap between the extruder that pushes the filament into the hot end and the hot end, you end up with buckling in the filament. It can fold to the side. It can slide out. So those can be kind of awkward. And a lot of people have problems like that. If you go and look at Steve's profile, he's got a lot of discussion about that and a lot of suggestions and advice on what kind of extruder, what kind of hot end, and stuff like that to use.
Thank you. What was his? I guess the last name of that gentleman, please.
Wood, I think. Hold on one second. Let me verify. Trouble is short for trouble with names.
Yeah, I think I thought it would be good to use it as the interface platform rather than having a rigid material being the first, interaction. I would rather have, like you guys are talking about, a cloth, wrap around the appendage. But then, also I would just kind of thinking having a soft interface between the Velcroed component. Just kind of an idea. I don't know if it's worth anything.
Here's a link to his profile.
Awesome. Thank you.
Yeah. Jesse, so there's something that that Jeff Aaronstone has been working on, and that is using the flexible filaments as cups and sockets and stuff for the arm design.
Mm-hmm.
So that is kind of similar to what you're talking about, but you're saying about the hand designs rather than the arm designs.
Well, I'm actually trying to work with a recipient right now that's without an elbow even. So I'm going to try to attach up in the bicep area with first soft interface. That's kind of a I guess a R&D thing that I'm working on with that family. But I guess I posted a couple pictures in the general discussion because I've used the Flexi hand design and the Raptor and the Beast before with like electromechanicals interfacing with the muscle sensor. And I guess this is going to be a little bit more complex in that there's a higher attachment point and then more need for versatility in the end of arm, because there would need to be some flexibility in the elbow as well as wrist and digits.
So forgive me if someone's already addressed this, but Jesse, are you working with that recipient through the mattress system, or was this a self-match?
Well, it was. I guess I'm newly registered as a volunteer, and it was advised that we request the match because the match actually materialized over your Facebook page, just over a random discussion.
So it's a self-match, but you have filled out the form and you're in the system now?
Yes, ma'am. I guess I've gotten confirmation emails and so forth, but in terms of having confirmation from the matching team to have acknowledged our desire, no, but it was definitely, I guess on my part, I made that clear in my paperwork.
Okay. Yeah, well, that's generally how we do it is that's something you put on the intake form, so you've done it right.
I apologize if I'm overstepping.
No, I said you've done it right so far. So it's just a matter of there is something that I've heard and come across that generally above elbow amputees, they seem to need some kind of a harness to help with doing that. So I was just wondering if that was something you guys were thinking about.
Yeah, I'd be interested in seeing what your plans are for actuating, where you're getting the motions from.
Okay. I guess currently I've taken photographs provided by the family as she, would provide a circumference and length measurements of the appendage that's existing, and from that I've designed what I shared in the general discussion page, which I can share again here. Or if I can do a screen share, I can show you the inventor. But
there's on the sidebar on the left-hand side of your screen.
Yes, sir.
The second one down should say screen share, and that should allow you to do a screen share. I may have seen your post already. I just.
Cool. All right, there it is. So.
Wait, before you share it, that's not the actual photos, is it? That's just Inventor, right?
Correct, ma'am. I wouldn't. I don't.
Right.
I wouldn't share that person's personal information like that. But yeah, I appreciate the cautious.
Yeah, thanks.
Sorry, I just had to ask before you did it. That's all.
No problem at all. So I'm not sure if there's any latency or anything. So please let me know. But I've.
Sorry, Trouble. Can you select Jesse's picture?
Done.
So, what?
It's done.
Okay.
So that he's showing for the people that are watching from home.
So what I've got is I worked the Raptor hand into the model, and back here in this orange area, I've taken their photographs and created what I feel would match the appendage currently, and there's a little bit of a skin and scar tissue as well. So I'm intending to run this component here in the soft materials such as like a TPU or a Ninja Flex, and then enclose that. It's kind of going to use the thumb pin component, just like on the natural hand, so I didn't have to kind of come up with that geometry. I'm just using the same concept for continuity within, you know, the parts, spare being used and so forth. Hopefully my inventor didn't puke here, but I apologize for the delay.
That's okay.
Yeah, it's CAD software. We're used to this.
It's starting to become a large file. I've also, you know, working on a design for the elbow that will not only print interlocked but functioning. So I've kind of used the Thingiverse model Robotica, as well as some other designs like, you know, Gail's design on InMove, and using it for some conceptual, you know, artist recommendation for how to make these things possibly functional, at least in the first portion, but I would definitely like to make it electromechanical. I've found some really rad servos on Servo City that I think will do the job. I'm just going to restart Inventor, but I apologize. I guess I can jump out of screen share or bring it back up here as soon as I get it relaunched. But those are, I guess that's kind of what I've volunteered to do, and I'm really getting engrossed into it and passionate about trying to, I guess, have it be in harmony with the hand design, so that way there's no real crazy, you know, excessive design work being done there, using the same concepts that have already been developed, but also, I guess, trying to work above the elbow.
Have you seen the XE design from Japan? That's actually an open source design now, and I thought it was, isn't it a motorized one?
I believe so, yeah. XE, EXII.
Not familiar with it, but I'll definitely try to hunt it down. You say XEII?
EXII, XE.
Actually, there's 3 I's, but yes.
Oh, right.
Yeah, actually, if you search in our Google Plus community, it has been posted in there. All you do is go to our Google Plus community and type XE into the small chat window underneath the picture, not the large one at the top, because that's searching all of Google. Oh, thanks, Nathan. Nathaniel.
Well, I guess I've done the same thing with the Flexi hand, in that I've got it servo powered and functioning off of muscle inputs. To this point, I've got a YouTube link that I can share for that, if anybody cared to see that. It's got a big whopping 30 views. But
have you posted it in our group yet?
I don't think so, ma'am. I just shared it with Advancer Tech's site, because they were the manufacturer of the muscle sensor. Here, give me one moment. Hi, I'm Jesse. I just wanted to show you the
sorry.
Channel and let's see, share.
Yeah,
I appreciate you guys bearing with my naivete, but and it's probably out of the context of your normal discussion, but
not really. Usually how we do things.
Yeah, we try to, as I put in the description of the event, I try to keep it as open a discussion as possible. We don't tend to have an agenda, so if you've got interesting things to talk about, we're usually accommodating.
Yeah, this is basically adult show and tell, or grown-up show and tell.
I hopefully that link will work for you guys. But it was some fun. It was fun to do it, and I've also shared the code that was able to be used for that process. I think I can illustrate the same function. I've talked with the young man's mother, and she ideally would want independent digit control, but that just adds to the, I guess, the cost of the bill of materials, because it's $50 per Advancer Tech muscle sensor, and you know, I'm trying to obviously do it all for volunteers' sake. I'm not trying to ask them to contribute for anything. Sorry. Oh, sorry, Nathan.
No, it's what he says is it's normal. We almost always wander off topic.
Yeah, as long as it's arm hand e-NABLE related, there is no such thing as off topic.
Right. You've even wandered off into discussions about water purification. So.
But yeah, I guess once I seen the discussion on the e-NABLE Facebook page, that's when I guess because I'd spoken or reached out before, but never filled out the intake forms. So.
Yeah. With your designs, I would maybe get in contact with the Limitless Solutions guys. They've been doing a lot of things involving myoelectric controlled motors for the hands, and they might have some suggestions that would be useful in the hand you're working on. Yeah, Albert Manow, the guys from University of Central Florida.
Mm-hmm.
Thank you.
Yeah, Limitless with a B, like limb, bitless.
I have a question for you, Jesse, about the arm that you showed us on Inventor.
Sure.
It looked like there was a socket, and then it looked like there was some sort of outer fairing between the socket and the elbow itself.
Correct.
The pins you showed us, does that just hold on the outer fairing, or is that fairing actually structural between the socket and the arm, then the elbow?
Well, I guess I'm waiting on the Inventor model to load again. I apologize. But yes, it's going to be more for structural attachment to the elbow joint or the elbow mechanism, because the elbow mechanism, or at least the way I'm currently envisioning it, is a two-piece component, and attaching to that will be the fairing, that as you refer to it, and that will provide me the I guess the traditional Velcro option, but I also wanted there to be an inner component to, I guess, soften the interface for the recipient. So the highlighted portion, to me, I think would be the soft, and then as you referenced this, the oranger object would be kind of an upper brace, and it's just structural to attach to the elbow, as well as allow for that socket to be, because I guess I put an intentional split in that socket component that I envision being soft, so that way it'd be, I guess, comfortable, as well as easier to, I guess, take on and off.
I like the socket idea. I like the general gist of it, the elbow joint and all. But if that fairing is structural, the orange member you're talking about, if the rest of the arm from the yellow elbow joint on is all supported by cantilevered out past that orange gauntlet, I'm not so sure 4 of those little press fit finger joint pins, particularly in the orientation they're at, will hold. I mean, not just in shear, but just in a straight separation. I would worry if that's the only attachment points.
Yeah, I agree with you. I've thought about possibly utilizing, real hardware and, inserting some sockets so that way I could slip fit a couple hex nuts in the yellow portion where I could have some recessed cavity for that. But I was just thinking in terms of weight at this point, because right now I'm just flying by the seat of my rear and trying to see what can happen. And
with bolts would possibly add a lot of structural support without increasing the weight significantly, depending on what type of bolts and nuts you use.
So,
yeah, even a printed, even a round printed hole that you could put a hex nut in, heat with a soldering iron, and melt into place. So you actually had a threaded anchor that you could then put. It doesn't matter, even if those were 1024 or something like that. 5 M5s, something along those lines. It doesn't have to be huge. M5, M6, 1024, whatever that range is. Anything other than those pins, I'm just afraid that it won't even handle the weight of the arm swinging, the stopping, doing a reciprocating motion with the arm, much less, lifting or bumping into anything. I think they'll just they'll probably detach. If you tried to lift any weight, they might shear, but I'm not thinking those would hold, but bolts probably would.
Yeah, the problem with a long arm is that there's a lot of leverage, and so a little bit of weight can create a lot of force. So it's
thank
worth,
you
it's worth thinking of,
for the input.
Yeah. Yeah, he's right. That is something worth checking into.
I definitely would not be contrary to, as you mentioned, putting like an M5 in there or something like that to do it effectively. I was just hoping to, I guess, using those pins and sockets to using continuity across the model. But I'm totally up for anything that would possibly just lend to his opportunity to be more adaptive with his left side.
Yeah, I understand the idea of trying to 3D print a lot, and in some, with designs especially that are designed to be printed out in remote areas or whatever, not using vitamins is nice, but in this case, when it's custom for a specific person and going with a little bit of hardware, just it isn't an issue, and threaded metal inserts can help a lot.
I intend to send my scanner to the family. I have a Sense scanner I intend to send to the family with the first iteration, and from that point we'll hopefully be able to scan. And now that I've learned the trick with working with the mesh, hopefully I can model around it.
Yeah, and as far as the cup that their residual limb goes into, it might be worth getting a cast of her arm using, well, just getting a plaster casting of her arm using alginate or something like that to get a perfect form of her arm that you could then. A lot of people have been using PLA with to heat it up in hot water to wrap it around a plaster cast of the recipient's arm in order to get a good socket fit. That's something that might be worth talking to Skip Meets about.
And Jeff Aaronstone.
And Jeff Aaronstone. They would have best ideas for that. I would absolutely recommend getting in contact with Jeff Aaronstone. He's going to have a lot of better information that will help you out since he's a prosthetist professionally.
Mm-hmm. Yeah,
thank you.
Sorry, Jesse, I was going to bring up the fact that we have an ARM team. Are you aware of that yet?
No, ma'am. Sorry, I'm still a little on the green to the orientation yet.
Oh, that's fine. I didn't even know how long you've been part of our group. So there's an ARM team. When did Skip say they meet? Like Friday at 1 p.m. Eastern? Was that what he said?
Something about Friday at 1 p.m. Eastern. Is that not the town hall meeting time?
No, it's not. 1 p.m. Sorry, 12 p.m. Eastern is the town hall meetings on Friday.
So they're doing a meeting after that then?
Yeah.
Okay.
So we actually do have an ARM team run by Daniel Dugan. So I would definitely say it'd be good to get involved with them. Jeff Aaronstone is on that team, and so is. I think they would really like to see your design. By the way.
Yeah.
Thanks. Appreciate that.
I might go find your post and tag their names to it so that they see it.
Yeah.
And that might get the ball rolling in that direction.
Yeah.
Because you've done a lot of interesting design, and I'd like to see. I'd like to see you talk it out with some more of the other ARM team designers. They've done some really interesting things that you might find useful.
Thank you. I appreciate your, I guess, allowing me an opportunity to ask questions, as well as putting me in touch with other people that have, expertise in the field. Because I just have a printer and was going to give it a go. Other than that, I'm still learning. So I appreciate your time. Thanks.
I admire the dive-in approach.
Yeah.
Oh yeah.
I hope to have one be able to send out by the end of the week. So,
just so you know, my official account and function in our group is volunteer support services. So feel free to add that to your circles and talk to me more, and I can help you get more oriented in our group and kind of get your sea legs and whatnot.
Yeah, she has multiple accounts, so it's worth finding all the Lydias and circling them.
Yeah, it's
thank you.
It's like a video game. Where are all the Lydias?
Collect them all. I'll get the whole set.
Yeah, and so that's what we do in our group. Is those of us who are well connected. Our point is to be able to get new people like you plugged in and connected with those of us that would be the right people to connect with. So, this is great that you showed up tonight.
Well, thanks. It was actually a suggestion of somebody to a comment on my post. So otherwise, I had not an awareness of the meetup group that was scheduled. So thanks to that gentleman.
We do these every other week. Although I might have to reschedule the next one or have somebody else host it. Mm-hmm. Burning Man is coming up, and I have got a ticket, so I'm going. I missed last year. I don't want to miss this year. This will be my 14th time. So I might have to get somebody to pick this up for me the Labor Day Monday, or we might reschedule it for Tuesday or Wednesday that week. Labor Day would be great.
Here was my attempt at proof of concept for the elbow.
Is that that's cool? Is that blacklight reactive?
No, it's just a translucent PLA green.
Yeah.
Very pretty.
But printed in.
Also, Jesse, I wanted to ask you, Trouble, you had mentioned that he speak with some of the people about from the Limitless group. Well, it just so happens that Wednesday I'm going to be at a lunch talk, whatever, with Tyler Petrusky, the co-founder of that.
Okay.
So what is it that would help from them? What?
Just getting him in contact.
What is it? Yeah. Well, Jesse, maybe you want to send me like a link or a what do you call it? It's just like a message separately after this or whatnot, and I can keep up to date on what they. It's more or less a talk at the Florida Hospital on how 3D printed prosthetics relate to it, and more than likely another opportunity for bragging and marketing of Limitless, but.
Yeah.
But I actually met these people as the first contact. The first time I got into this, my very first meetup in town, just happened to be two of the students from there showing off the first Alex hand before giving it to them up near but not at the Johns Hopkins conference last year. And but it was funny because I went to the meeting and it was billed as come meet people from e-NABLE, and I had just signed up and didn't know anything about it. And I met them, and they didn't seem to know much about e-NABLE, which surprised me because they were showing a hand.
Yeah.
But it turned out it was because they were with Limitless, so they didn't really know, current e-NABLE programs, etc. But it just by coincidence, Bob at Delta Maker asked me if I was going to the thing at Florida Hospital, and it turns out it's them. So now I'm going.
Nice.
So I'll get a chance to talk to them at Limitless and pass on your info. But being somewhat new myself, that was a pretty impressive looking file, at least. So.
Yeah. We had a myoelectric team set up to try to start designing myoelectric controlled arms, and then one of our hangouts on air, Albert Monero with Limitless, came on and gave us a brief demonstration that they had a functional 3D printed myoelectrically controlled arm they were getting ready to give to somebody, and that was a pretty fun hangout.
Oh, bad. Yeah, and not to take anything from them, but when I saw it, I mean, it really basically was a flexi hand attached to a pretty crude arm that had no more than an Arduino and a couple of circuits. Or maybe it was a Raspberry Pi, but something along those lines. And it was 3 months later that Little Bits now has a muscle-activated bit. You can, play with. You're familiar with Little Bits, of course.
They were getting their.
But they came out with them.
What is the name thing again? Their EMG sensor is manufactured. It was one that was being shipped a lot with a couple of different electronics companies.
I got mine through Pololu, but it's made by Advancer Tech, and it's a V3. I've asked them multiple times to see if they could just put more than one channel on a single board rather than having a need for 5 channels and 5 separate boards. But that would be a fantastic thing. The code was pretty simple, and you got full proportional scale from your muscle signal that you can use to drive a servo. I was impressed. I mean, it was as easy as I could just take sample code, having not written or be an Arduino expert. It was pretty darn. I took sample code and it was pretty easy. Yeah. Thanks for posting that link. But the sample code's actually in the comments of my YouTube video.
Nice. The guy who runs Advancer Tech is also in our community, and he's posted a lot of things. I'm going to pester him again, see if I can drag him onto one of these hangouts, because I think it would be fun to actually have a long chat with him. See what, basically give him a forum that he can show off some of the things he's selling and get some more discussion about how well it works and what it's doing. But yeah, they've got some pretty cool stuff, and a lot of what they've got with their newest MyoWare device is from feedback with working with the Limitless guys. So a lot of their newest chips that they just finished a Kickstarter for are designed with the Limitless guys in mind, so us in mind as well. So they're worth looking at.
Well, I guess that's awesome that they're a part of the community as well. So I guess I get fortunate to have joined the right group.
Has Thalmic ever released the API for the MyoBand?
I don't know.
Well, it looked like it had great potential, but it wasn't hackable. I mean, they would just, it'd be perfect if they'd released the API, but they, as far as I know, they didn't.
Yeah, as a video game control system, it looked promising, but there was a lot of the things that it seems to be able to do they strained my credulity a bit. They seemed like they were claiming to be able to do things that seemed difficult to do with myoelectrics. And without custom placement of the electrodes, it seemed a little outside of my, I'm not sure how they'd be doing the things they're claiming to be able to do with the equipment they seem to be using.
Well, you got to remember, it's not myo only. With the gestural control, they leaned pretty heavily on the fact that there were accelerometers in there.
Right,
so
that makes sense.
The movement of the arm, or it was a combination of things. I think they leaned a little heavily on the movement and rotation and all that of the arm, along with the gestural control. I don't think it was myo only. They couldn't have done. You're right. They couldn't have done those things by themselves.
Yeah, or with myo alone. So I've been interested in their stuff. I don't think they've released a API for their equipment yet. But I haven't.
That's a good question, or a good point, because I had a hard time trying to discern where to mount the pickups on. If it weren't for the video on Hulu's site, I wouldn't have known where to put the lead terminals from the sensors.
Let's look. So yeah, Thalmic Labs, thalmic.com is the website for the Myo. I'll post the link. Also, I've been noticing and hadn't brought up comments on the ball bearings, things you've been discussing in the sidebar, Nathaniel. I think that those are potentially of big use with anything that involves movement that also involves a lot of strain and stress and weight, and might be things that Joshua is worth looking. It might be worth your while to look at the things that Nathan has been saying in the sidebar about ball bearings for joints. He was talking about skateboard and roller skate ball bearings as things that can handle the extra strain of the rotations and stuff that you're looking at with that arm.
Oh, and look on eBay. You can get tubes of 10 of the things for like $3. I mean, sometimes they're really cheap.
Yeah.
They've got them in all different sorts of ID and OD. I mean, we have some at the shop that are like 7/8 ID and 1-inch OD. I mean, they're like, really thin-walled. Some of them have, down to 3 or 4 millimeter holes in the center of them. You can play around. They make little tiny ones, really big ones, thin ones, thick ones, double row.
Yeah, they come in a lot of sizes and they make a lot of motion, really, really simple. Yeah, and the other things he was saying in the sidebar, like using PVC pipe from Home Depot to for some of your length structural pieces. It's a cheap part that has some good structural capabilities and sorry, bud, and that it is useful for a lot of these kind of things.
That would be beneficial. One of the servos that I guess kind of pointed a blanket link to, but they're made specifically for tube attachment points. So tube attachment would be, I guess, eliminate the need for a lot of printed component. But I guess that's the dialogue that I just initiated today with the family was, do we want to produce or go after mechanized right away, or should we just try to shoot for fit because, the ugly cost rears its head, and I'll definitely purchase them, but if it turns out to be a servo that doesn't work, then I don't want to have a $110 paperweight that doesn't do any good for the family or myself. So.
And that's another reason we should get you in contact with the Limitless guys, because they'll have good advice as to which servos to use and what ones are more reliable and have good weights and things like that.
Keep plugging away, but your first arm's never going to be right. It's going to be something in development. You're going to be tweaking and replacing parts for a long time to come. That's nothing personal about you. That's just the way it works. Even if you got a team of people, it's never right the first time. It's always a work in progress.
Yeah, even little Alex, who received the first of the Limitless arms, has had a couple of upgrades since the beginning. One of which, if you look for it, Robert Downey Jr. delivered a Iron Man themed arm to him that was made by the Limitless guys, so that was kind of cool.
Yeah, I've seen that, and thank you, Eric. I appreciate that, and I kind of had the mindset knowing there were at least going to be 6 revisions at a bare minimum if I'm lucky. But at least this time it's for a good purpose, because in the past I've always built these printed objects for just recreation, and now there's actually somebody that's going to be able to be benefiting from it. So for that purpose, it makes it I don't know, it kind of energizes me some. So
yeah, it's fun to have a goal. You learn a lot when you have an end in mind. It makes learning how to use the tools that you're playing with a lot more fun. You know what you're going for.
I'd like to point out, I'll say this verbally this time, PVC, one of the biggest concerns is, I believe it leaches out chlorine as it decays. And so it might eat away, like they've got the plastic tarp and stuff that they might use for greenhouses. So it actually eats that, and I don't know how the chlorine or whatever it is that leaches out might interact with skin. So that is something I figure I would bring up. I mentioned PVC is a possible option, but it's
Right.
like that possibility.
Yeah,
that
and it might do damage to the other plastics that are in use in the arm, and it might also not be great for skin contact.
Yeah, so it's like, it's a maybe, but we've got to do some checking and see how that might actually interact with those.
Yeah, good to know.
Speaking of side effects, I guess, of using these hands and stuff, Eric and Jesse, have you guys come across any information about the effects of prolonged skin contact with flexible filaments, or also with what kind of off-gassing there might be from printing them?
That's a good question, and no, I don't have any hard data on either of those two things.
Yeah, somebody asked that in the group the past couple days. I didn't have any answers, so I didn't say anything.
I also don't have any information, but I guess I can possibly throw a beta out there and print 2 identical elastic type wristlets or something like that. Wear them for a couple of days or extended period if there's any adverse effects. That definitely wouldn't be something in vain, I guess, because that's a curiosity I have, hoping to make that socket component soft.
Mm-hmm.
Yeah. I was also going to make it porous, so that way it didn't sweat or trap moisture. You know what I mean? At least put a couple vent holes in it.
Yeah, it could be that Jeff Aaronstone already has done some research about that, since he's trying to do that. Of course, he was doing the Monet socket, or Monet socket, and that's actually made out of PLA, and he has been thermoforming it, but also when it's still pliable, he's been basically making it playing with it like Play-Doh to get a truly customized socket. So, but that's PLA. So I don't know. I mean, maybe the ARM team has come across some of this before. I just haven't been to any of their meetings yet.
The manufacturer may have some data, but honestly, in this industry, so much of it is seat of the pants, almost fly by night, that I'm not sure if anybody who makes filaments has actually had any of that stuff certified for what it puts off, both the VOCs or anything when it's printing or long-term skin contact.
Well, there has been some information about PLA and ABS, at least printing it out, and possibly some effects on the skin. So at least those two have been. We've got some of that in the community. You just have to search for it.
There's also I can't think of his name. One of the filament manufacturers has a FDA-approved filament that you can use for water storage or for holding food when you're done printing whatever you're printing. It's worth doing a search for FDA-approved filament. I would suspect something that is safe to store hot water in is probably safe to have against your skin. And it's also worthwhile to, Peregrine and Peter have been saying this for a few years, that anytime that they've got contact with skin, they like to use leather, because we know how leather affects skins.
Right. We know a lot of data about leather, actually.
Yeah, we've been using that forever. So if you can find a way to build or line the inside of a cup with leather, that might be something that can improve. Yeah, Peter Binkley and Peregrine Hawthorne. They're father and son, and Peregrine is the recipient, and Peter's the designer, and they've done a lot of really, really cool things with the hands that they built. Peregrine is also our primary tester. He does a lot of the really damaging tests with the equipment that we're playing with. So a lot of the hands that have been destruction tested were destruction tested by him.
Destruction over time. He likes to say his tagline on the e-NABLE forum, which is different than the community. It's I break hands and then I tell you how I did it.
Yeah. He did a lot of things early on where he was like cutting weeds with a tool that he was swinging around, like a machete or a sieve or something like that. He's clearing brambles out with one of his 3D printed hands and that, and he would tell you what finger joints would break and when. He could tell you a lot of detail about where the weaknesses in the hands were with that kind of heavy-duty abuse. And he has one of the nicer-looking hands in our, because a lot of it is, custom designed. He does detail work in the leather when he makes the leather palms and the leather on the braces. He does a lot of really, really interesting things with his talent hands. And what's the new one that he's got? The Osprey?
Yeah.
That they're designing right now? That's one of the hands that is in test right now.
Mm-hmm.
Still undergoing design revisions, I suspect. So anything else? Anybody else have anything they want to bring up?
Oh, Jesse, you're muted.
Was it the Osprey by Alderhand?
Yes, that's them. Alderhand is them.
Okay, yeah, I've got that one. That one's very interesting.
Yeah, Jesse, have you signed up for the forum yet?
I apologize. Which forum we were referencing? The e-NABLE forum on Plus? Yes, ma'am.
No, that's the community.
Okay.
So
there's
yeah,
there's an R&D forum.
Yeah, we can talk about it later.
Okay.
Yeah, it's in the sidebar chat if you scroll back a ways.
Okay.
Speaking of which, can somebody update copying the sidebar chat into the document? Whoever was doing that, thank you. And we've added like a few more pages since then.
Yeah, maybe we should wait till the end of the call. That way we get more of it.
Right, that would work.
I've been trying to keep up with it as it goes. I've updated it a couple of times.
Oh, thanks, Eric.
Okay, cool. Thanks. Yeah, that does help. Yeah, I don't have a lot else to bring up. So if there are any other questions people want to talk about, let's bring them up now, or we might be at a good time to wrap up. Yeah, it's 9. We've been on here for
2 hours.
Yeah, almost 2. Yeah, 2 hours. We started about 15 after, I think.
Hello.
So,
Hi, Joshua.
Hello.
Hi.
Hello.
Can
Can you hear me?
Yeah, 2 hours. We started about 15 after, I think.
Can you hear me?
Yes.
Anyone?
Your voice seems to be muffled by something else in the background. Do you have the YouTube version of this playing on another device?
I had a question about the 3D printer heads.
Okay. Yes. Your voice seems to be muffled by something else in the background. Do you have the YouTube version of this? Go ahead and ask. Okay. I'm not sure Joshua can see the sidebar chat because it kind of feels like he's using his phone to connect to the conversation. But there's another way around that, I suspect. Oh, so he does have sidebar chat. Okay, cool.
I think we can hear you typing, Joshua.
No, that's me.
Oh, okay. I was gonna say his microphone does work.
Yeah, it sounded, because of the delay on the feedback I was hearing, it sounded like you might have another tab opened on another device watching the on-air version of this, watching the YouTube Hangout on Air broadcast. And that might have been what was causing the feedback. What are you trying to do with 3D printer heads? Are you just looking for general advice on what the best printer heads are, or are you looking for the best printer head for a specific type of filament?
Now I can't hear you at all.
Okay, we hear you, Joshua.
Okay. Yeah, if you go back to our previous Hangouts on Air, I think we had a good 5 or 10 minute discussion about printer heads on the last one, the one 2 weeks ago. So if you go to my profile, you might be able to find some of that where we were discussing what printers are best for various purposes. If you're having a specific problem, go ahead and post it into a comment on this Hangout on Air event posting, and we'll do some discussion offline with that maybe. It might also be possible that we can discuss it in a Hangout that's not on air, just your phone and my phone talking back and forth or something like that. So if you want to go off air with that, we can do that, and I'll try to put the conversations. There's a CNC and asked about printer heads. Oh, so you were talking about the types of 3D modeling devices that can... Oh, okay. Yeah, Eric talked about that last week, 2 weeks ago. The E3D printer heads are the best for general purposes, and the extra cost is worth it. Okay. I'm mostly repeating that aloud so that people that are watching the Hangout on Air can hear me.
Well, if you're set up for CNC milling, your machine is going to be far more rigid than is required for 3D printing. So you've got that covered, so you can do a direct drive head easily. The difficulty is your screw pitch and what your acceleration ramps are going to be. A metal cutting mill isn't going to be able to reach the speeds a 3D printer needs. If you've got a wood router, that kind of CNC, your screw pitch and your acceleration should be perfectly adequate.
All right, cool. Anybody else had anything they wanted to bring up or talk about?
If you haven't signed up for the forum yet, go ahead and do that soon so you can be part of the R&D discussion when we're not doing the Hangouts.
Yeah, let me post that in the sidebar again. This is the link to the forum. You'll need to set up a separate account on that, or you'll need to set up an account with that. And but it's a lot of the design discussions go on there instead of on the Google Plus community, because the PHP-BB software allows you to post images inline in the comments, and Google communities don't. So design discussions are a lot easier to do if you can pass images of models back and forth.
And it's also easier to find things in the forum than on the Google Plus community.
Yeah, not as many introductory conversations happening there, and we've got a lot more subdivision of the forums set up, but it's a little easier to keep things separated from each other.
And the search
tools is really nice.
Yeah, they seem to be better than the Google search tool, which is kind of ironic.
Yeah. Yeah, I always wondered why the search isn't as good in the Google communities as it should be. I tend to use the search tool built into Gmail to find things. I've got all notifications from Google from Google Plus going to, or from this community going to my Gmail account, and that gives me a much better tool for searching for previous discussions. That's why I +1 a lot of conversations that might be useful later, because that makes sure that the sub-discussions end up showing up in my email box so that I can search them a lot more detailed later.
So you basically have the Google Plus community in your Gmail.
I do. Not 100%. I don't always +1 the introductions, and I don't always +1 a lot of other things. Every new post I see, but I don't always see the comments on the posts unless I've +1 the post.
Yeah.
So posts that seem like they're going to have answers that contain good information, I will +1 them so that when the conversation happens, that also ends up in my email box, because that's Google's search engine in Gmail is much better designed for finding things than it is in the communities and in the Google Plus. Much more effective. Did I show you this, Lydia?
Yeah, I saw the post on that. That was pretty cool.
Yeah, I like the rotating gears.
Yeah, now all you got to do is make that out of brass and stuff, and you'll have your nice little steampunky one.
Agreed. My brother is a Rubik's Cube fanatic, and so I saw this online and ordered one, and I'm probably going to give it to him when he gets back into the area. But I might start looking to see if I can find models to print one, because we can print with brass, so that might be fun.
Yeah, print with bronze fill.
Right. And it might also be interesting to actually follow through on the experiments I've been thinking about for a while with conductive filament and then electroplating. I'm curious if that can be done with interesting metals. Copper would be fun.
So, wait, is there copper fill?
I think there is, but I think that actually plating the outside of a printed object with copper would be kind of fun.
So I don't quite understand electroplating. Can you? Are you saying that you would use bronze fill and then you would plate that, electroplate copper onto that?
No, I'm thinking just using conductive filament. Electroplating, you need a medium to conduct the electroplating through, and hopefully it has to be something that's not going to dissolve the plastic. But if you put the metal that you want to plate on one of the electrode leads, and you put the thing you want to plate, you want to put the metal on the other electrical lead, and run a current through a medium, usually water or an acid of some sort, the metal that is on the one lead will migrate to the external surface of the other device that is attached to that lead. It's a method used in a lot of jewelry making and stuff like that. So it's yeah, that's what I was wondering. I haven't experimented with enough of the conductive filaments, but and I also worry about if the conductive filaments also all about the base, no acid. I'm going to be spending my next, the week after next, I'm going to be spending a week out on an alkaline flat, so I'll be very much all about the base.
I guess I got some conductive filament, not from Color Fab, but I tried to make a relay base out of it using my dual extruder, trying to plot some actual conductive traces within the body of the object, and I felt like it didn't necessarily live up to the hype, but that was maybe 8 to 10 months ago before I guess there have been more advances in materials.
Right, and it might be something that we could print it with one of the metal encased filaments. I worry about the metal encased ones like bronze fill and stuff like that, because I worry that that it might not conduct electricity all the way through it. There might be enough of the PLA or ABS medium that the particles are embedded in that it might not carry the current through the whole thing.
I mean, if you just put an ohm meter on the spool, it's pretty poor.
Yeah, with the
conductive.
With conductive filament. Yeah, I'll give that a try. I'll plug my multimeter into bronze fill the next time I purchase some, because that's interesting too. That if there's a better medium to do electroplating, I'd be curious to see. It'd be fun to actually build one of these hands electroplated with copper or with bronze or with aluminum, and just build robot hands that look like robot hands.
You can get some cold coatings, Playdolls or Luminor. Luminor, if you're looking for looks, that's something that's non-conductive, but it's basically almost atomic fine metal suspended kind of in some sort of a catalyzed resin. You can spray it and then polish it and all that. It's like 95% target metal. It's what they do in movies to make fiberglass outfits look like metal or whatever else. That's the way they do that. If you're looking to plate, they do make actually a spray-on conductive paint, and it is enough that you can spray it on. It looks awful by itself, but you can spray it. It's a copper base, I believe, and you can spray it on composites and then use that to electroplate, I believe, a heavy base coat of copper on top of it, and then I think you have to flash plate it with nickel or something else before you move. You have to plate it a couple of times with different things to get up to, depending on the metal you want to plate it with. But I know you can use it as a base to get copper onto.
Right. Yeah, that would be fun to play with. I'll start digging around and see what I can find on spray-ons. I don't know how much structural improvement you would get from electroplating, but
none.
Yeah, I wonder if it would do something with the shear at all, reduce the likeliness to shear between the lines, but I wouldn't suspect it would.
It's not even microns thick. It's usually nanometers. I mean, you're really not talking about much.
Right. If the graphite.
Now, electroforming will actually allow you to build up. Electroplating is one thing. Electroforming is where you actually build up layers, and there you can add a few thou, but it's still not a huge amount. But you can actually build up several thousands on top of composite items at that point.
Yeah. Well, one of the things I was thinking about is with a conductive filament, if the conductivity was higher, you wouldn't just be electroplating the external surface. You would be getting some electroplating inside, maybe not.
Talking about doing some sort of infill of voids?
Yeah.
Hmm.
Yeah, I don't know if it would help anything at all.
Depending on your composites, I'd worry about the residual effects of the acids.
Right. The plating medium.
Yeah, It's because capillary action is going to pull that stuff right into any voids in the filament and in the print itself. Now there's some cold spray stuff. Luminor is probably the best. Plate-all is probably the easiest. I believe Luminor actually has to be purchased. The raw materials are purchased by somebody who's licensed in an area to apply it as a commercial business, because it's a little picky to get right. Plate-all, I think you can just buy itself and put on at home. It's what a lot of the steampunk people do to make everything look like brass.
Right. The company I work for has a chrome shop, but I don't think I could do any personal things with it.
Actual chroming, or?
Yes, I work for a company that makes equipment for mining purposes.
Because you know most things can't handle the heat, the temperatures, and the acids that they use to actually do chromium plating.
Right.
Okay.
Right, I'm thinking outside of the realm of 3D printed things.
Yeah.
Like, it'd be kind of fun to chrome plate a bike, or, you know, weird things like that. Unlikely though. I'm the only programmer, or I'm the only solely a programmer at this company. We make a lot of mining equipment that a lot of the mines use, and I write a piece of software that controls water trucks that allows you to use GPS to regulate the water output and make sure that we also can track water usage so that you can make sure that places that got really dusty, make sure that they're getting adequate water, make sure that areas that are hills that get slippery if there's too much water are not being overwatered. It allows central management of a lot of the mining companies to keep track of what's watering where and when, and also use rules to define what kind of watering goes on. So I play around with a lot of really high-end industrial equipment, but mostly as a programmer.
One of these days I'm going to have to talk to you about some of the stuff that we're doing, integrating. Even, you know, at one point we even looked into hand pneumatic integration and some of that stuff, but decided to write our own for different reasons, because it doesn't matter.
Yeah. The idea of hand pneumatic integrated into something like Octoprint has an interesting idea in it.
Yeah, we had our Beagles running them for a little while so that people could basically not have to get it emailed back to them. It ran both ends, you know.
Right.
We weren't sure what e-NABLE's direction or support or future development of any of that stuff was, so we just kind of went with our own. But not averse to it. It's just one of those things that we couldn't wait around for e-NABLE to figure out when they wanted to do something with it.
I think a lot of what's going on with the hand pneumatic development is that the lead developer for that project has other employment that has been eating up a lot of his time. So.
And now Ro is also in that boat, and all of our other developers have gone dormant as well. So the whole pneumatic has been dormant since May, I think. So we're trying to figure out what to do. I mean, I guess we're just going to be waiting around for a while, but we're dormant for now.
Yeah, I don't know if you guys, maybe I guess you guys probably saw it in pictures from the last Maker Faire we did, but there was a large printer sitting there with, you know, the e-NABLE logo burned on the front of it. That was actually what was running the hand pneumatic, and we kind of had it set up that possibly it was something that could, you know, e-NABLE could possibly move forward with, and it didn't look like, you know, if software development picks back up, I'm more than happy to play. But we've gone other directions in the meantime. What is this?
This is a laser with a cylindrical lens. crossing the beam. So it can take a laser beam and turn it into a fan instead of a... And there are projects, people have used these to make 3D scanners. And I'm...
Add 1 or 2 webcams and yeah, you pretty much have it.
Yeah. Yeah, a couple webcams, maybe a mirror to get the light to go around corners.
And a lazy.
What's
I
that?
do not recommend the Sense.
You don't recommend which?
The Sense by Cube. Sorry.
Oh, right.
That thing's a brick.
Yeah, I don't anticipate this actually turning into anything exciting, but it seems like a fun project that I want to work on. You can kind of see the way the cylindrical lenses are. There's several of them so that you get a longer line, and they are perpendicular to the beam. So the beam goes through it, fans out, hits the other ones, and fans out more, and you end up with a line. You can cast a line onto things. So if you get the line to go perfectly vertical against a turntable, you could put something that you want to get a scan of on the turntable and a camera, and then rotate it 360 degrees and get a pretty decent model if you've got the right software to read the position of the red line.
Effectively, the camera sits off axis of the line, and
right.
It picks up basically the parallax shift means it picks up an irregularly shaped line based on the shape of the object, and as you rotate it around, it can grab that and stitch it back together. Gabriel picked up some software. There's some open source stuff out there. There's some various things. You might want to ask him what software he got. His was about $100. Said it was the best thing he could have picked up. It works flawlessly, and all he really needed was basically a laser pointer and a wine glass stem and a webcam. Which, there's your cylindrical lens right there. You've got one built in.
Yeah, I spent a little time trying to find cylindrical lenses, that were perfectly cylindrical, so that I wouldn't have to spend a lot of time making sure that the laser beam hit it at the right angle. But then I just found that I could actually purchase this laser component cheaper than the lenses were going for, and it's designed for this, so I might as well run with that. This was like a $5 part, I think, maybe a $15 part.
Fabulous.
Yeah. So that's my next interesting project is going to maybe be that. All right, Lydia. I'll see you. I'm going to go ahead and end the broadcast. I think we're wandering far enough off topic at this point. I was mostly trying to fill space because they were having a discussion in the sidebar chat that I wanted to let them have time to get through it, talking about Joshua's printer arrangement. So I think we've covered most of the topics that we can tonight. We're about to run out of time anyway, and I'm starting to get hungry, so I think I'm going to end the broadcast. Now. Thanks for joining us, guys.
Thanks.